Welcome to the Math Record. Today I'll be covering the first part of the integration of trigonometric functions. In this video and in the next video, the integration of these functions are going to require the trigonometric identities. For this video, I'm going to be covering the power functions, which are going to be sine of x to the power of n and cosine of x to the power of n. So the first case I'm going to cover is when n is equal to odd. So let's say we want to find the integral of sine 7x with respect to x. So first we're going to take away one of them. So that's sine of 6x to the power of 6x, and then times sine of x dx. And then from there, what we want to do is that we want to make this to a squared, and then it's going to have some kind of power. So it'll be sine squared of x, and then 6 divided by 2 is 3, so then it's power 3 times sine of x. So all we have been doing is just rewriting it a different way. Now we're going to use our trig identity, which is the Pythagorean one. Sine squared of x plus cosine squared of x equals 1. So since we have the sine squared of x, we're going to substitute 1 minus cosine squared of x to the power of 3 times sine of x dx. It was cosine of x, you're going to substitute 1 minus sine squared of x. Okay, now we're going to now whatever's in here, we're going to do a u sub. So this one's cosine squared of x, so we're going to substitute u equals cosine of x. It was 1 minus sine squared of x, we're going to substitute sine of x. Now do the derivative. The derivative of cosine is negative sine. So we're going to move the negative here. So then we have negative du equals sine of x d of x. So we see this is right here. So we're going to substitute this one in. So we have the integral of 1 minus cosine of x is u. So this is u squared times negative du. Okay, so when you multiply this out, including this negative, you're actually going to get the integral of u to the power of 6 minus 3u to the power of 4 plus 3u squared and plus 1. I'm not going to take time to show the math, but basically this is what's going to expand out to. Okay, and when we take the integral of this would be u to the power 7. The derivative is 7u to the power 6, so you need to scale by 1/7. U to the power 5. So the derivative is 5u to the power 4. This is 3u to the power 4, so we need to scale by 3/5. So the integral of this is u to the power 3. The derivative is 3u squared, which is this, so that works. And the derivative and the integral of a constant is just u. And sorry, I forgot to take away the integral. Okay, now let's delete this portion because I'm running out of space. And as usual, you add a c. And now since we have our integral, all we have to do is just substitute our u back in. So that's cosine 7x minus 3/5 cosine 5x plus cosine 3x plus cosine x plus our c. And that is our answer. Okay, so that's what's when it's odd. So we just had to use the Pythagorean identity. Now, if n was even, we're going to have to use the double angle identity for cosine. So let's say we have the integral of cosine to the power of 4x dx. We're going to have to make this a square, so that's the integral of cosine of square root of x to the power of 2. So 2 to the power of 2 makes the 4. And we're either going to use cosine of 2x is equal to sine equal to 1 minus 2 sine squared of x, or cosine of 2x is equal to 2 cosine squared x minus 1, depending on which one you have. Since if we're working with the sine, then we're using this one. That means we're using this equation. Since we're using cosine, we're using this one. That means we're using this equation. So rewriting this equation, since we're not using this equation, we're using this one, then rewriting this, we have cosine of 2x plus a 1, and then we divide by 2 equals cosine squared of x. Okay, let's substitute that in. So we have 1/2 cosine of 2x, put parentheses, plus 1, close parentheses, squared dx. So 1/2 squared is 1/4, so get that out of the integral. And then cosine of 2x plus 1 squared. So this thing squared would just be cosine of 2x, cosine squared of 2x, plus 2 cosine of 2x plus 1 dx. Okay, now from here, we see that we have another square. We can't deal with those, so we're going to plug it back in. So instead of an x, we have 2x. So substituting back to this formula, we have 1/4 the integral 1/2 parentheses cosine 2. We substitute 2x into this x, so 2 times 2x is 4x. And then we add 1. And then we have the rest of these terms. So plus 2 cosine 2x plus 1 dx. Okay. What we do is take the integral of, actually let's factor the 1/2 out before it gets any more confusing. So we have 1/2 times 1 is 1/2. 1/2 plus this 1 is 3/2. So let's add this one first, and then we're going to add 3/2. Okay. Let's delete this because we don't need it anymore. And we're going to have to do some math. So we have 1/4. The for cosine, to get to cosine, we know that the derivative of sine of x is cosine of x. And that means using our chain rule, we know that sine, this is in big parentheses, so sine 4x. The derivative of sine of 4x is cosine of 4x. Chain inside means derivative of 4x is 4. So this is 4 cosine 4x. We want 1/2, so we need to divide by 8. So this is 1/8. Plus, so this would be sine of 2x. Derivative of sine of 2x is cosine of 2x. Chain inside, derivative of 2x is 2. So that matches. So it's just this one. Plus the integral of 2x is just, of a constant, is just a linear term. And then we add a c. Multiply to 1/4, so that's 1/32. Sine of 4x. Sine of 4x, not the power 4x, just 4x. And then 1/4 sine of 2x plus a 3/8 x plus a c. And that's the integral if our cosine of x is to the power of 4. Well, thanks for watching, and in the next video, I'll cover the rest of the integration of the trigonometric functions.